Here we are given a single logarithm, and we are being asked to decompose it using the properties of logarithms, including sums, differences, and expressing exponents as factors. So in red, I've provided you with a list of some properties that we're going to use, and this says that the log base A of a product is equal to log base A of each of the factors added together. Log base A of a quotient is equal to the difference of log base A of each of the m and n, and that log base A of m raised to the r is the same as pull that exponent down to the front, r times log base A of m. So first let's look at what we have here. Our argument is x to the 14th times the square root of 3 minus x. So we wanted to use this property. And we can rewrite this as the log of x to the 14th power. Since they're multiplied together in the argument, we can separate them and make it a sum as the log of the square root of 3 minus x. Now it also says to express exponents as factors. So we see that in our first one, our exponent is 14. So using this property, we will rewrite that as 14 natural log of x. Now what do we do with the square root of 3 minus x? So recall that we talked about how we can write the square root of x as x raised to the 1/2 power, because even though there is not a 2 here as our index, it is the square root. Similarly, the cubed root of x would be written as x to the 1/3 power. The fifth root of x would be written as x to the 1/5 power. So let's rewrite this as the natural log of, we're going to take 3 minus x and raise that to the 1/2 power. Because now we can go back and use our exponent rule of logarithms again. And we have 14 natural log of x plus, pull the exponent down in front of the natural log, 1/2 times the natural log of 3 minus x.